Juan. Go ahead.
Okay. Hi everyone. My name is Caitlin, and I'm facilitating this room. First, I'd like to introduce Maddie Tharp. She's doing bioplastics, and please don't get up and leave the room and silence all your phones. Thank you.
All right. Hi, everybody. My name is Maddie Tharp, and I'm doing bioplastics. So I'm sure many of you have heard about the problems that plastics cause. But for those who haven't, I'm just going to give a brief overview of that. So petroleum-based plastics cause a lot of problems, such as turning into microplastics when they degrade or start breaking down into smaller pieces. These microplastics can easily enter digestive systems of any animals and easily affect and pollute the environment. Annually, plastics can kill about 1 million marine animals, and almost all species of seabirds have been found with plastics in their digestive systems. The world produces about 448 million pounds of plastic each year, and that is expected to double by 2030. Other problem with plastic is that UV rays cause photodegradation, which also creates off-gassing of methane and ethylene, which are greenhouse gases and can further climate change. Another problem is that when fossil fuels are used to create plastics, the polymers in plastic, they often create a lot of chemicals, and a lot of chemical additives and toxins are put into the plastic to keep it from breaking down quickly. So the difference between regular plastic and bioplastic. So all plastic is made up of molecules called polymers, and polymers are further made up of smaller pieces called monomers. There are thousands of different kinds of plastics, but one of the most common kinds is polyethylene, which is made up of carbon atoms and 2 hydrogen atoms strung together. And over here is a little picture of that. Whereas starch-based plastics, which is the base of many bioplastics, is a little bit more complicated, but the main structure is glucose, which in theory should break down when bacteria digest it. So most plastic can't actually compost or decompose or fully break down because the bacteria in the soil can't break down what the plastic is made out of. So petroleum, most bacteria cannot break down petroleum. However, in theory, bioplastics should be able to be broken down by bacteria because of what they're made up of. However, many bioplastics can be engineered to be nearly exactly the same as petroleum-based plastics so that they won't degrade for thousands of years. So when plastic is actually breaking down, like I talked about before, petroleum-based plastic will degrade into microplastics and microfibers, which can spread all over the world very easily in ocean currents, through rivers, and even through natural abiotic and biotic processes in soil and through flora and fauna. Most bioplastics can actually not break down in backyard composting facilities, as many people assume. They take high levels of heat and perfectly controlled humidity to break them down, which is why many of them, if left outside in nature, won't break down and actually can take about the same amount of time as regular plastics. Also, bioplastics often have the same amount or more chemicals in them to prevent them from breaking down in different elements than regular plastic. So left outside, they can easily leach chemicals into the soil and into the environment. So another thing to keep in mind is that things labeled as compostable on packages they actually mean that they need industrial composting facilities to fully break them down. So again, not in your backyard compost heap. Also, many of the regulations placed on bioplastics are done in very controlled settings in laboratories. So putting them out in the ocean, they may not actually break down the same way that the scientists and researchers actually expected them to break down. And a good example of this is a little straw in the jar. On the package originally, it said it only took 90 days to break down. It's been approximately 300 days, and this is saline water, not exactly as, doesn't have the exact pH of the ocean, but it's a good example of how this could, how the actual regulations could be slightly off. So sustainability is a big question here. Bioplastics draw on a lot more natural resources than regular because you have to grow the actual plant, which takes land and fresh water that could be used in other ways, and it takes more energy to actually create them, which for our area in the Four Corners region, because of this drought that we've been in, this is not sustainable to be using fresh water. Durango also, or the Four Corners region, also doesn't have a commercial composting facility, and to ship bioplastics takes extra amounts of CO2.
That was the end of the 5 minutes, sorry.
That's fine.
Are there any questions?
What was the pH level you used for the straw?
I don't actually remember. By the time I actually tested it, it had been, I wasn't actually keeping track of this because I started this before I started making the presentation.
Ah.
Yeah.
Thank you.
Any other questions? Yes.
So, you said that some of the stuff that's not compostable, you can't just put in your backyard
Yes.
stuff. Do you know like what kind of stuff is okay? I mean, other than food scraps, like can I put my paper plates?
Mostly yes, except it depends. Some paper plates have coating of wax or plastic on them sometimes, which makes them not be able to break down. Some of them, yes, maybe, but also some of them labeled as compostable do actually need facilities to break them down.
Any other questions? Okay. So thank you for your amazing. And now it's on to Isaiah McCrady with Water Wars.
My project's name is Water Wars. My big question was, what material will keep water from flowing through it the best? With my hypothesis, it was if water is filtered through sand, potting soil, plastic wrap, and styrofoam, and the plastic wrap will prevent water from flowing through it the best because it is not porous enough, therefore will work the best for keeping floodwater out. In 2019, floods caused $45.9 billion in losses and nearly 4,500 deaths in the entire world. Floods not only can cause money problems and fatal harm to people, but are extremely hard to prevent. If you love animals, dogs, cats, well, floods are fatal to them too. Sad but true. The question you need to ask yourself is, would you ever want your family to be separated? No? Do you live in a frequently flooded place? Then this experiment is perfect for you. Even if you answer no to one of these questions, this can be good for if you go on a vacation to one of your family's houses or anywhere where floods could happen. To test this out, I put the different materials into the corner of a pillowcase and poured 40 milliliters of water on top and waited 3 minutes for it to flow through and saw how much water came through. In the end, dry potting soil and dry sand worked the best because they just absorbed the water. My hypothesis was incorrect because the plastic wrap, I put it in a clump so it just drained around the sides and didn't actually catch. So in this experiment, I was testing what materials prevent water from flowing through the best for flood damage. My hypothesis was incorrect, as I said, because of the plastic wrap, it just flowed around the sides. In the future, I put these in full pillowcases or sandbags and splash water against them to more simulate a flood. Yeah, that's it. Any questions?
and now it is on to Kassandre Kuss. Is that how you say it? Okay, with temperature and ocean currents.
Hello, my name is Cassie, and my project is called Temperature and Ocean Currents. For this project, I wanted to find out how temperature affected the velocity of ocean currents. The main purpose of this project is to show the currents of ocean water being affected by temperature. Global warming I thought that global warming has a big impact on ocean currents, because I hypothesized that warmer water would make the currents move faster. And if with global warming is warming up the water, then the currents would move faster, and this would cause bigger waves and also sea life. This could affect sea life, such as where they live. And so this would help. So knowing how temperature affects these currents would help scientists to understand more about sea life and waves. To make this experiment happen, I had 3 beakers of water, one 15 degrees Celsius, one 20 degrees Celsius, and one 30 degrees Celsius. And I put a drop of food coloring in that would show the velocity of the currents. So I took pictures to measure it. So when I first dropped it in, this is the 15 degrees Celsius. And then after 2 minutes, you can see it just spread a little bit. This one was a 20 degrees Celsius. I dropped it in and it spread quite a bit. And then after 2 minutes, it spread faster, and it was more towards the bottom. Then 30 degree, it spread fast. And then after 2 minutes, it almost turned the whole thing blue. So it proved that warmer water makes ocean currents go faster and spread more. I predicted that the water would move faster in warmer water. I knew that molecular movement is faster. Molecular movement in water is faster in warmer temperatures. So I imagined that the molecules would definitely have an effect on the currents. And so, and on my results, it proved my hypothesis to be correct. Overall, the experiment went well, and sorry, and my hypothesis was correct.
So do you guys have any questions?
Yes. Do you think what you learned from this experiment, how do you project this will affect the oceans?
Ocean creatures would, if their ocean creatures are used to different currents based on like where they live. So like deep sea creatures, obviously there are less currents in the deeper sea. So if the water becomes warmer, then they would be less used to that and have to find someplace else. Or ocean waves become bigger and dangerous, could wreck coral reefs and other things like that. So, yeah. Yes.
Do you think this would help the Great Barrier Reef in Australia come back from the bleaching it had in 2019?
Well, that is a bit different problem. It's not exactly the waves hurting it, it's more human waste and things like that. So I wouldn't say that this would help that problem exactly.
Any other questions? Okay, so at 10:10, that's when the session ends, and then we'll have a 10-minute break until 10:20, which will be the next session. So please stay in your seats and don't get out of the room. Thank you.